Hello and good day to you. You're once again welcome to MS Constructions, where we discuss all things engineering and architecture. Today, we will be learning how to do our building analysis in Protastructure. But before further ado, we encourage you to subscribe to our channel if you like our videos. We encourage you to also give our videos a like or comment on our videos so that we can know what you think and to encourage us to make more videos like this as well. Let's get straight into the lesson for today. Now we have this structure here. We've been working on this for a while. We want to perform a building analysis on this, and we'll be assuming that it's just having a roof right on top of it. We are supposed to put a beam here, even if there's going to be a roof going on top of it, but we're not going to do that. We just want to focus on doing a building analysis for now. To perform building analysis on this, what you need to do first is to ensure that you have decomposed all your loads from the slab to the beams and the columns. Well, for now there is no foundation. This is acting as a pseudo foundation for this structure. So let's go and decompose our loads. We've already decomposed the loads for this particular project. Child element size 800, mesh uniformity factor is 25. We leave it as default there, and this is our story height, and story height is 3.00. We go here and press OK, and we press OK. So it's performing a decomposition of loads. It's performing it, so we allow it to do its thing, and then it's done. And when it's done, it pop-ups with this, so you can read this. I'll just go here and press OK. Once I do it, it's going to pop up with this question. So I want to apply to all beams in the model, so I'll do this. So now I have my load decomposed, and now I have to go and adjust my settings in my analysis tab. So I go to building analysis right here to adjust my settings. So first I need to go to this pre-analysis tab to edit material. For columns, I will choose 1620. You could actually choose other grades, but I prefer 1620 because I'm designing for the worst. You should always design for the worst conditions on site, especially if you are not going to be the one to execute the project. For our C1620, you have 24,000 Newton per meter square as your modulus of elasticity, and you have your characteristic strength, the FCK, as 20 Newton per millimeter squared. We can go here and press OK. Then we want our REBAR to be grade 410. Also, this is also in line with trying to design for the worst possible conditions on site, especially in the case of we are not being the one to execute the project. You still want the project to be safely executed. Okay, that this particular project only has columns and beams and the slab. I'm going for my beams to be the same thing as C1620. Then I'll be adjusting my slab also to be 1620. Then all others, I'm going to leave it there. I don't have ribs, I don't have walls in this particular project, so I don't need to adjust anything. So I'm also going to go to REBAR diameters. I want to have just 16. Sometimes it clicks a lot of bar to use, and you have to just pick the one that you actually want to use. You can actually select or unselect all here, you understand? Then you can now go and pick the ones you want. Consider using Y16 for my columns. So I'll press OK here. Then I'll go to my slab. I want to use Y12 for my slab. Then I also go to my beams. I want my beams to also be 16. So in case you have multiple number of bars selected, you can just select and unselect. Then you go to select the ones that you want. If it's Y16 or Y20, I will go with Y16 for the purpose of this project. So I'll press OK. So I'm done with that. So I'll press OK. We can as well just go and set our load combinations. You can do that here. You can also do that, here. You can also do that in loading to set your load cases. And in order to set your load cases, you can just use load generator to set your load cases. You have defined dead loads. These are very compulsory. You need dead loads, you need live loads. Then you could create factored G combinations, for steel only, for steel and concrete. I think I would prefer to just take this, create on factored G plus Q combination. What it does is that it adds extra loads that may be acting on the structure as dead and live loads. But I'm going to disable this because I don't have pattern loads. And I go to my horizontal. What I just need here is just a notional loads here and here. I'm not using crack sections, and there is no wind loading problem for this kind of structure. It's too small for that. So I just click OK here, and you see this is my unfactored G plus Q. It's not really compulsory for this kind of project, but I just had to put that here for you to just see. So I could remove it because it's not really very useful right here. I could just go create my normal G plus Q. We don't need to apply P data analysis. Also, the reason is because this particular structure is very small, and there's not going to be any need for designing for secondary deflections and all that. So I'm not going to be applying P data analysis here. So approximate standardness checks using moment manipulation method will be applied. Generated our load cases. So let's press OK. Then let's go back to our analysis. So what I want to do additionally here is that I want to go to model option. I'm going to leave this at default. Then I'm going to go leave this one too as default settings. And for now, we are not merging foundation in model, so we are going to use user defined support. And these are the user defined support that we have here. They are springs. We don't have a shear wall. So the slab model, I want my slab to define rigid diaphragm. I want to include slab in building model, and I also want to use composed load in my building analysis. So my slab stiffness coefficient, I'll leave this as default. I want my shear element type to be 800. I think default is 1000, but I changed this to 800 along the line. So I'm going to just leave it as 800 for now. So I don't need to include columns in my FE model. So I'm going to leave this to as it is clicked right here. We're going to actually leave all these here like this. I don't also want to use path solver. Now it says here story weight and center of gravity calculation. Use decomposed beam loads. Use undecomposed slab loads. If you remember, our slab loads are what is decomposed onto the beams, and the beams are decomposed to the columns. So now it says here that in a particular story, if there are slabs that are not transferring their loads to beams, story weights and center of gravity must be calculated based on undecomposed slab loads. And if you look at this structure properly, you realize that there are no part of this structure that is not transferring its slab loads to the beam. So we don't actually need to use undecomposed slab load. We can, however, use decomposed beam loads. So now we can go straight to do a building model check before we perform our analysis. This ensures that everything we designed is properly done, and it says building model check complete, number of errors is equals to 0. So we can close this right here. Then we go from here to do our building analysis. So we want to actually design, not just analyze. So we go here, we go and do the building analysis. So wait a little bit, this shouldn't take long because it's a very small project, mini project I should say. So now it's properly done, so it will bring out our report, and we'll be able to see deflections, our displacements and all that. But before then, we need to check our Axial load comparison report. In order to do that, click on that, and then it brings this out. So we have our dead loads to be total of 1859, live loads 225 for the Axial load comparison report, and we have our building analysis report to give us dead load as 1858, which is not really too far from this. From what we got here, from the loads that decomposed to beams, we have 1858. For the live load, we have 225. So there are no discrepancies, and that's why there are no notifications popping up here. And everything is okay. It means everything is okay. Because if notifications pop up here, it will ask you to go and make adjustments on your design. So now we can close this and go and check at our analytical model. Yeah, let's click on displacement to know what our displacement looks like. So you have these dead loads here. This is live loads, notional loads along x and notional load along y-axis. So for the dead load, you have this. Our maximum displacement is 2.875, and for the live loads, it's usually a lot smaller. So now we can get for our G plus Q, our dead and live loads, that's 4.6, which is okay. And these two, it seems from here our model is okay structurally. So we can also check for our design status by going here. Then we go to our 3D, and you can see that our design status shows that our structure is indeed okay, as all parts of the structure is designated green. You can go here to check your columns. You can also go here to check your beams. And in case you want to check the entirety of all your columns, you can just go back to your analysis, the building analysis, then go to post analysis, then go to column mode design. You can see that everything is checked here, and you have all your columns before Y16 at 175 spacing. The length is Y10, while the steel bars, the main rods, are Y16. That's that. Then you can also go and check for your beam reinforcements. So you see that your beam reinforcements are this. You can go to interactive design. You need to adjust this, and you can turn this up to 3Y16. You can adjust this to 2Y16 and then 3Y16, and then you OK this. It's always good to design your beams one after the other to know exactly what is obtainable. You can't just rely on the software to do all the work for you. So okay, so you can check everything one after the other to make sure that what is designed is implementable on your site. 2Y15, no, this is not economical. Go to 2Y16, then we turn it up to 3. This is 2Y16, then we turn it up to 3. And that's okay. So you can go to this, it's okay. You can go to this, it's okay. Then you can go to this finally. We need to turn this to 2Y16 and turn it up to 3. 2Y16, then turn it up to 3. So okay that. And when you go back, you see that your design is still very much okay. You can transfer this analysis to your drawings and reports. This is all for now concerning the basics of video analysis in Protastructure. Don't forget to hit the subscribe button to get more videos like this. Thanks for watching, and bye for now.